First of all, you know about the parametric interval Markov chains model. You know about checking consistency for interval Markov chains. But now we'll see what happens for parametric interval Markov chains. The consistency problem can be seen as different questions. So the first one is, does there exist a parameter valuation V such that the interval Markov chain obtained with this valuation is consistent? So for a particular valuation. Another question is it possible for all valuations, all parameter valuations V, to say that the corresponding interval Markov chain is consistent? And an interesting problem consists in computing all parameter valuations V such that the corresponding interval Markov chain is consistent. So now we'll see how to check consistency in parametric interval Markov chains. The inconsistency constraints that we have for parametric interval Markov chains are composed of a local consistency constraint for a state with respect to some subset of successes and something global. The local consistency of a state S with respect to some successes in a state S prime is such that the sum of upper bounds must be greater than 1 and the sum of lower bounds must be smaller than 1. And also, of course, the lower bounds of the intervals must be smaller than the upper bounds of the intervals. So the inconsistency constraints for parametric interval Markov chains are such that the constraint for a state S is given according to some cutoff successes. So we have a constraint for a state S that is given with respect to a set X of cutoff successes. And this is the local constraint we have just seen before for the state S and the successors of S except those in X. So in X we have cutoff successors, those we won't consider. And this constraint must be intersected with the constraints on the lower bound, saying that for all cutoff successors we should have a lower bound equals to 0. Intuitively, that means that in X I have successors that I don't want to reach, and therefore I must have a probability 0 to reach these successors. So 0 must be in the interval, and there's no choice, it must be the lower bound, and the local consistency must be satisfied by all other successors. So that is for 0 consistency, and if I want n consistency with respect to X, I will have to apply n-1 consistency to all successors that are not in X and also check local consistency of these successors. Plus check that for all successors in X, the lower bound is 0. The consistency constraint for the state S is then the union of these consistencies with respect to X for all X that are included in this set Z of S, where Z of S contains the successors of S for which low is either 0 or a parameter. So if it's 0, we have automatically that the lower bound is 0, but if it's a parameter, we will have that the parameter must be 0. So given a parametric interval Markov chain with n state and an initial state S0 with a parameter valuation V of I, so the interval Markov chain corresponding to this valuation is consistent if and only if V is in const n of S0. So let us take the example we have seen before. So in this example, we can derive that the consistency constraint is this one. So this consistency constraint is only on Q, and it says that Q is either smaller than 0.7 and bigger than 0.3, or Q is equal to 1. This part of the constraint corresponds to this part of the PIMC, so where Q is comprised between 0.3 and 0.7. Okay, and the second part where Q equals 1 corresponds to taking this branch of the parametric interval Markov chain. So at this stage, you know about parametric timed automata, you know about their problems and algorithms, you know about interval Markov chains with parametric probabilities, and in the next session of the tutorial, we'll be practicing with imitator on parametric timed automata.